In this video, I will be talking about Angular SHM. So, Angular SHM. So, what is the difference between Angular SHM and normal SHM? So, results in normal SHM, we obtained that function will be x is equal to a sine omega t plus phi. So this was the equation of SHM. So we found that velocity will be a under root omega under root a square minus x square, while in normal SHM we had f is equal to minus kx. Okay, and we found that a will be is equal to minus of k by m, or this a was minus omega square x, or a plus omega square x will be 0. These were the results of normal SHM. But when I am talking about angular SHM, so here displacement will become theta, because we need angular displacement. So angular displacement will be given by theta is equal to theta naught sine omega t plus phi. So what do I mean with this? Here a was the amplitude, here theta naught will be the amplitude of, so this will be not amplitude, angular amplitude. Okay, so maximum angle it can cover, right? This will be angular displacement. Omega is same, theta is same. Here this will be not force, as we are talking about angular displacement. That means we are interested in torque will be is equal to minus c theta. So there k was a constant, here c is a constant, so torque can be written as I into alpha in rotation. So alpha can be written as minus c by I into theta. You have seen this is k by m, so this is c by I. So you know that in rotation mass is not only the important parameter, here moment of inertia will become parameter. So alpha plus c by I into theta will be given as 0. So this is the analogy of normal SHM, where angular SHM is, this is angular acceleration. Okay, so c, we have to see this is a constant. So the result was t is equal to 2 pi under root of m by k. Here the time period result will be 2 pi under root of, instead of m by k you need to write I by c, correct? So now we have to see how do we obtain this result, and then we can figure out on the basis of this angular SHM the time period of simple pendulum and all other stuffs, right? So let us remove this. So this was the analogical part, this is important. So in this video further I am going to do, let's say for simple pendulum. So the major task is to find out the time period of this pendulum. So simple pendulum is like this. Suppose there is a string, there is a small bob which has mass m, and this is a string of which is having tension T because of this bob, because mg force is downwards. So this is our string. So we are assuming that this is string is massless, and we cannot extend inextensible, right? So we cannot extend string like a spring or in elasticity. So suppose that this pendulum is vertically suspended by the spring, by the string, right? And this is our bob. Suppose that we displaced this bob with a certain angle theta like this. So now you can understand there will be certain amount of oscillations start happening like this, which I have done with light white. So I wanted to know if theta is a small angle, then find out the time period of SHM. So now first of all understand this is SHM, how we have to prove it. So now I am trying to draw this diagram like this. Initially Bob was at this position and then Bob at this position after having some displacement. So this is our Bob now. mg, if you draw the FBD, the mg force will be downwards. There will be tension in this string at that moment, and let us say up to this maximum height Bob can reach. So if you draw the FBD, then what is happening here at this moment when this is at O, or let's say point P, what is the amount of restoring torque about the point H, right? So write torque about point H. So tau H will be is equal to, so the value of torque is given by, so there will be, this is line of action of this force mg is this, so this is going to be the perpendicular distance which is x, and obviously for this tension this is passing from this point H only, so 0 into tension T because of this tension T, okay, and plus because of this mg, now perpendicular distance. So now understand this force mg is trying to draw this pendulum like this, you know that pendulum will go like this, so that definitely this is the perpendicular distance, and we know that torque is given by r perpendicular into f, magnitude of torque. So mg into perpendicular distance is x, this will be generated torque, and we know that in rotation torque about any point will be given by moment of inertia about that point and into alpha at that point, okay. So that means this torque will become, so if I'm writing the restoring torque, so this will be IH into alpha, obviously in the minus sign because that will be in opposite direction. So minus IH into alpha is equal to mg into x. So from here I can write alpha will be is equal to minus mg by IH into x. This is our value. Now we have to obviously simplify. So if you see this triangle, let's say AHPA for example. So in triangle HPA, what you can see, this angle is theta, then this angle will be theta. So let me draw this correctly. So this is going to be the HPA, point P, H and A. This is x, this is theta, this is L. So I can write x by L is equal to sine theta. So from here x is equal to L sine theta. So we can substitute, and also moment of inertia about point H. So this is our small particle here, which is how much L distance away from this point. That means ml square will be simply moment of inertia. So if you substitute that here, so minus mg upon I hinge ml square into x, which is L sine theta. So this is cancelled out, m and m cancelled out. Let me remove this. Which is not needed now. So here what I achieve, alpha is equal to minus, this is only this time g by L into sine theta. Now initially I assumed that theta is small. If that is true, then sine theta will be approximately equal to theta. We know this is for small angles. It is true in maths. So basically I can replace, so I can say alpha is equal to minus g by L into theta. So sine theta is replaced by theta. Now recently I have seen that in angular SHM equation will be minus omega square into theta. So we can compare those two equations. So if you compare, on comparing alpha equations, we get minus omega square is equal to minus g by L. So this minus minus is cancelled out. Omega is equal to under root of g by L. Right? So we got the value of omega. Now we know that time period is equal to 2 pi by omega. So this will be 2 pi under root of L by G on putting the value of omega which we recently calculated. So that's how we calculate the value of time period of simple pendulum, and that is the concept of, based on concept of angular SHM. Okay, yeah.